Hi everyone, this is a demonstration of the CSLC library for Csound, and I'm going to talk through a live coding session so we can see some of the features and what it does. Alright, let's begin. We've got Csound running there in the console. We've loaded up a library of sounds already, so some of these instruments that we're going to make are going to look relatively simple. But we're going to look at the CSLC library in terms of what it can do to make the music using these sounds. Let's begin. We start with a simple analog kind of sound. Call it DFM1. Use this UDO I've made. Takes P4, P5, P6. Evaluate that. Attach it to the output. See what it sounds like. P6 on the end. Not bad. My immediate thought is we actually need to add an envelope. Okay. Much smoother. All right. Now let's get some sort of ongoing process running, because while it's fun to generate individual events, we want to get a bit more active. Just as a quick explanation of what's happening here, there are functions here to convert time. Next beat aligns it with a clock. The next beat on the beat on beat 1, and tempo dur is play this note for a duration of 1 beat. In this case, our tempo is 60, so that's effectively 1 second. Let's generate a loop event. Now this the first array is a parameter in this UDO, and we will give it similar parameters as what you see above in that event, but we don't need to do conversions for the tempo or pitch when it's included in the loop event UDO. We give it another array of pitches, -2 and 0. 0 in this case is middle C, and by default we're in a major scale, so it's actually going to be a minor biad A and C. And let's just keep it simple. Let's just give it these parameters. So 3 arrays. The event, same parameters as what you might see in a scheduled event, pitches and rhythm. There's already a few things we can do to play around with this. I can add pitches to that pitch array. It's an array, so we can do arithmetic on these. We can do the same with rhythms. Sometimes it needs to think a little bit about how to align itself when we're extending extra events, but we'll see how this sounds. Not too bad. Bit of a disco rhythm. Let's make a copy of that. Increment the instrument number. And maybe add a harmony. Or maybe a polyrhythm might be nice. It sounds a little bit hot, so I'm going to reduce that down. There, levels are a bit better here. Okay. So now let's we can play around with this a little bit more. Let's change this top pitch array. Rand array or Rand array gen takes in parameters from low to high, number of events, and let's little flag at the end to decide whether it's integers. So it generates an array full of random values. Let's make it super obvious. Let's put it up here. Now you might notice that is repeating. I'm gonna but every time we evaluate it, it gives us a different pitch array. I like the sound a bit more. Now, I could spend my time re-evaluating this over and over, but I think I'm going to put this in its own loop code. Loop code is like a loop event, except it evaluates arbitrary code. So we'll set it to re-evaluate every 6 beats. Give it a unique ID. Just helps it keep track of its state. Can be any string really. Wrap all this in a multi-line string and just evaluate that. So you can hear that pitch array is re-evaluating itself every 6 beats. Let's do some simple chord changes. Iterate through an array. Array just takes an array and iterates through a series of values. So let's give it 0, drop an octave, an extension, an ID value. Don't think we need to worry about anything else. Need to wrap that in parentheses. But anyway, we've got an IPit value there, so let's feed that into the pitch values of this pattern. Okay, that works. Let's add a few more. Increment the instrument numbers. same pitch. And just give it a little bit of buzz down the bottom. That sounds a bit squelchy. I think I need to... Yeah, that sounds pretty good. Shorten these notes a little. Now it's sounding very mono. Let's widen it. We can add an effect. We use an effect construct. It's just a kind of boilerplate template to actually generate an instrument. All we need to do is fill the code in the effect processing code inside. The reason we generate an instrument is because doing it this way lets us reevaluate and replace any running instances on the fly. So got a delay UDO that I've already made. Let's call it AOUT1 delay frame. Got an input delay time 3/12 feedback filter instances. Okay. Make a second channel, different time. Get rid of the double comma. Now we've got two outputs, so we send them out. You'll notice we've taken the input from an array. It's taking a single mono input. It's outputting in stereo, so we need to output both channels. And the parameters at the end tell the effect constructor what channels are going to be output. So 1 for input, the first one, 2 for 2 outputs, and I'll add an extra one. We can add a crossfade in seconds. So a crossfade for maybe 2 seconds, because this is a delay instrument. Let's evaluate effect. Let's give it a better name. Delay. Okay. Let's evaluate that. Now we've got to patch the sound. I'm going to use patch chain. This chain just takes an array of strings. So we go BFM1 goes to delay, which then goes to outs. Let's see how we go. Yeah, that sounds pretty good. It sounds a little bit, I'll just temper the volume just a little bit. Okay. Let's add some extra effects. Strings. Yep. Strings. Do we need an envelope? Maybe we do. Outputs, strings to outs. See how that sounds. Okay, I'm going to put that in my loop up here. And we don't need to calculate the next beat. For the duration, just give us a second on that one. Put that in high pitch. Just make it a little bit quieter. No, duration, there's actually a variable in this loop code I can tap into called loop duration. It actually plucks the value from here. In this case, it will be 6. The loop code also takes an array of values that it will iterate through as it recurses each time. That loop variable will always be updated. Let's see how this sounds. Arpeggiations going in strings too. Intervals. For the intervals, let's generate an array. 0 to 21, uneven increment, the onsets, something really quite now ARPI. It's a bit like loop event. It's an arpeggiator, but it takes a duration. So for the duration, I think I'm going to leverage that variable again. Does that work? Sort of what I want, but go up and down, so I think I'm going to switch these around. 21 down to 0, increment slightly differently, and let's concatenate using cat array these two arrays. Or I would if I had remembered to put a comma in there. Okay. It's a little harsh to my ears. I'm going to add another effect. Thicken the sound. Ensemble ST takes is a stereo effect. Mono input as usual. It doesn't have to be a mono input. You can have stereo inputs as well. You just add an extra index into the ANs array. Depth number versus 3. One input, two outputs, crossfade, 1.3 seconds. Okay. another nice thing we can do with these arpeggiators. There's an event parameter. I think I'll give it a value, so it's going to pile up those notes in the first 3 seconds. Add something called active damp. Just tempers the volume, so as notes pile up, it doesn't blow the volume out. Maybe drop 6 decibels. Too much. Got a stuck note. See that up there? Okay, what else can we do? A melody. Let's add another instrument. Actually, no, I like it like that, but I might I'm getting glitchy, so I might. I already have a drum kit locked and loaded and ready to output, so this is cheating a little bit, I guess. And my pitch values are just it's called drum hits. Actually, -2 means the raw values go through instead of getting converted by pitch, and I'm going to put on a rhythm gate. Let's introduce this gradually. Rhythm gate is a kind of chance occurrence of an event happening. Let's add a rest. Okay, that's the taster. I think you get the idea. Anyway, you're welcome to explore CSLC at your leisure and see what you can come up with. Now, here's the only thing. How do I stop this? Thanks for watching, everyone.